Okay, sorry about that, got cut off. So we were evaluating this function, and actually there's really no reason to square this out. Even if you did square this out, you would still end up with some square roots in square root of 6x's in the terms, and that would still just mean x is greater than or equal to 0. So I'm going to leave it like this and call it a day. The only real reason to square that out is if you're looking for your answer in a set of multiple choice answers and you see that they FOILed it out, right? And our third scenario here is, what about f composed with f? So you can compose a function with itself. That means f of the square root of 6x. So again, domain restriction of x greater than or equal to 0 should make it to my final answer. All right, and then that means the square root of 6 times the square root of 6x, right? Because we're putting in square root of 6x in for this x right here. Okay, so what does that mean? It might be helpful to look at this as going into, like, this is 6 to the first, this is 6 to the 1/2, and this is x to the 1/2. It might be good to change that radical into exponent form, just so that we can kind of look at what we have. Like, let's see, what is 6 to the first times 6 to the 1/2? That's 6 to the 3/2 times x to the 1/2. All right, and then what does that mean? So this is 6 to the 3/2 times x to the 1/2 raised to the 1/2 power. Okay, so what do we have there? We have 6 to the 3/4 x to the 1/4. Well, what does that mean? That means that both of these are under a fourth root. We have 6 to the third, which is what? 6 to the third is, let's see, 18 plus 3 is 216. And then we have x to the first under here. All right, so now I see that the function is fourth root of 216x. Do I need to get any new restrictions from that? It's still an even root. It's still that 216x should be greater than or equal to 0. So in general, x should still be greater than or equal to 0, which carried over anyway from the inner function. Okay, evaluate using the functions above. Again, show two ways to get the answer. So I'm just going to do this once. The long way is find f composed with g of x using the functions above. So we did that back here. We got 3 radical 2 times x minus 2. Now we already did that work, so that when I say that's the long way, it doesn't feel that long, but we would have done all that work. And then you would plug in f of g, and then you would, let's just say this, and then you would plug in -3. If you do that, that's not bad. That's 3 radical 2 times absolute value of -5. But what if you didn't go through all the trouble of finding f composed with g to begin with? Then that could be pretty lengthy. So your alternative is just, if I want to find f of g of -3, it's important to know that that's f of g of -3 like this. So it's important to know that you can find g of -3. So what is g of -3? Let's see. G is 3 times x minus 2 squared. So g is 3 times x minus 2 squared. That's 3 times 25, which is 75. And now it's find f of 75. So f is the square root of 6 times x, right? Now, do I want to do 6 times 75 and then figure that out? No. Remember, if you're trying to simplify large numbers underneath square roots, you can break them down. 6 is 3 times 2. 75 is 3 times 25, or 5 squared. I can pull a 3 out. I can pull a 5 out. And I can leave a 2 underneath. So 15 radical 2 is my answer. Now again, that seems a lot more complicated than getting f composed with g and then plugging a number in. And maybe this is. But most of the time, it's faster to evaluate the inner function, get that answer, plug that into the outer function. Let's see if it's okay for this combination. So this means g of f of 2. So if I plug in f of 2, that means I have g of the square root of 12, right? Because f is the square root of 6x. And let's just clean that up. Oops, that's g of 2 radical 3. Okay, then g's function is 3 times x minus 2 squared. Now I just leave the answer like this. If we don't want to leave the answer like that, then we've got to square the whole thing out. But again, it depends on what we're looking for. I would consider that to be simplified. All right, and then f composed with f of 6, so that's f of 6. That's f of the square root of 36, which in other words is f of 6. And that's square root of 6 times 6, which is 6 again. So that's kind of a weird one because you just keep getting the same number back out. All right, what about combinations with a calculator problem? So take a look at this. You need your graphing calculator. The number of bacteria, N, in a refrigerated food is given by N of T. This is domain, remember? Where capital T is the temperature of the food in degrees Celsius. When the food is removed from refrigeration, the temperature of the food is given by T of T, 4T plus 2, where lowercase t is between 0 and 3. That's another domain. So we have a domain of N and we have a domain of T. Part A is find the composition N of T and interpret its meaning in context. So if we plug T into N's function there and there, we would get N of T. That'd be 20 times 4T plus 2 squared minus 80 times 4T plus 2 plus 500. All right, now remember, when you're doing domain, you've got this inner function that says t needs to stay between 0 and 3. The inner domain needs to be satisfied. And we don't have any capital T's on this side of the equation, so I don't need to worry about stipulating in capital T should be between this and this. Restricting lowercase t to 0 to 3 is the only thing that we care about. That's the only variable, the only input on the right side. Interpret its meaning and context. So composition is weird to think about, but remember, N, the outer function, is still a number of bacteria. And the original function was number of bacteria based on temperature, but now it's number of bacteria based on the time, out of the fridge. So how do we interpret that? This function is a model for the number of bacteria in the food T hours after it left the fridge. Something like that. Okay, now part B says, find the number of bacteria when T equals 2. Now, I can type this all into my home screen. I can type in 20 plus 4 times 2 plus 2 squared, blah, 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 blah. That's not that hard. But I do want to show you, again, just some more calculator tricks that can make life a little bit easier. So go to y equals, clear out an old equation. Let's type in this equation with its parentheses and everything. So 20 times 4x plus 2 squared minus 80 times 4x plus 2 plus 500. Okay, That's what we just put in y equals. You can graph this if you want to. We might as well practice graphing. Window, set the domain 0 to 3 for t, and then zoom fit. Okay, there's our function. Fun. But what do we care about? What I want to find is n of t of 2. Okay, I can do that on my calculator. What I want to do is figure out when the value is 2. There are two ways to do this. If you can see the graph, go to second trace value and type in 2, and it'll show you 1700. Or if you didn't get the graph, or you couldn't get the graph, or whatever, you can still do function notation. We want y1 of 2, basically. So we want alpha trace y1 of 2, 1700. So either way, I get 1700 bacteria, right? And now I said n of t of 2, but really what I should be doing, which I think is okay to say, but really I could just say, I think I could just say, no, I'll keep it like that, sorry, n of t of 2. Okay. That's the same as not saying n of 2. That is like if you plug in 2, what do you get for temperature? You get 10 degrees Celsius, so that would be plugging in n of 10. So anyway, n of t of 2. And then part C, find the time when the bacteria count reaches 2,000. Okay, now this would be kind of a tricky, or it'd be an annoying, like quadratic formula problem to solve. But what C is saying is when is 2,000 equal to 20 times 4t plus 2 squared minus 80 times 4t plus 2 plus 500. So the long way to do this is square all this out, get the thing equal to 0, solve for t, right? The short way to do this, because you have a calculator, how you should do this is get the thing to graph. And again, if you didn't follow that, that was window, domain, zoom fit. And then go back to y equals and type in 2,000. Now, if 2,000 doesn't show up here, which it does, but if 2,000 doesn't show up, then you zoom fit again and make sure that it fits your window. But 2,000 fits, so this point of intersection, second trace, intersect, enter, 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 tells me the time where that happens. We always round to at least 3 places for AP Pre-Calc and AP Math in general, so 2.222. T is about 2.222 hours for the bacterial count to reach 2,000. All right, that's it for today's notes. We will practice some more tomorrow.